you're moving on your x value from 0 to 2 pi. The rectangle's moving, it's getting bigger, smaller, going down below, and then back to 0. Do y'all see that? Like rectangle moving and growing as it moves? That's what's happening. When you're integrating, you're basically just moving across, adding up these tiny slivers as you go from left to right. Interesting. All right, let's talk a little bit about some of the properties of definite integrals. I think there's about 8 of them here that I have listed. I'll go through these pretty quick. The first property is that if you integrate a function from a to a, your answer is 0. Does that make sense to you? Why is that 0? If you're going from a to a, you don't have anywhere, right? So you're like, okay, the function's up here and you want to find the area straight down on just a single line. And that doesn't have any area, so your answer is going to be 0. The integral from a to b of f of x is equal to the integral from b to a of f of x, but negative. So that means if you switch your limits of integration, so we did this problem just a second ago. What was that answer? 728 over 6, right? What would happen if I switch it and I wrote it this way, 3 to 1 instead of 1 to 3? The only difference would be that the answer would be the opposite sign. So if this is positive, this one would be negative. If this one was negative, this one would be positive. Three, we don't really need. 3 is really not important. 4, 5, and 6 are, I think these are pretty obvious. Let's see. What does this first number 4 say? Constants can come out. And we knew that already, didn't we? This just gives it to you for sure, all right? Maybe it was different for definite integrals than indefinite, but no, it's the same. Then this next one says, if your function is always above or possibly touching the x-axis, 0, right? If your function is always greater than or equal to 0, then your answer must, your area underneath must be a positive number, right? Or 0. If your function is negative or below the x-axis, then your integral, the area underneath, will be negative. Just like that sine curve, right? That first arc of sine, it was positive. The second arc was negative. This next one's 7. I know some of y'all are trying to write these down. I'll post these online for you so you don't have to copy them. And I think they're in the book too. This next one says, if you have A is less than C is less than B. So let's say that's A, that's C, and that's B. Then A is less than C is less than B, right? That you can do the integral from A to B, that's the area all the way from here to here, by splitting it up into 2 integrals. And you can just go from A to C first, find that area, and then add up this area, and it's going to give you the same answer. That seem reasonable? Okay. This one says, if your function is even, that means even functions are symmetric over the y-axis. So even functions, when you reflect them over the y-axis, they land right on top of each other. That if you're going to try and integrate from negative a to positive a, now this is important, these have to be the same numbers, just opposite in sign. So that means I'm going like from negative 3 to positive 3, or I'm going from like negative 1 to positive 1, or like negative 10 to positive 10. That, what can you do instead, according to this? Just go from 0 to a, So instead of going from here to here, just go from here to here and then double your answer. That seem reasonable as far as visually? Okay. What if I change that even to odd and leave everything else here? This to this, this. What do you think this will be? If it's an odd function, think about what odd functions look like. What do they look like? Or are you giving me an answer? Zero. Yes, good. So a good example of an odd function is a sine curve. Sine curves are odd. So odd means odd functions are double reflections. It's reflection over y followed by reflection over x. So if you go from negative a to a, right, negative a to a, then these two are always going to kill each other off. And so your area will be nothing. Good. There's a problem in the homework where there's an integral, and it goes from like negative 4 to 4. I'm making that up. And then there's some integrand here, and then if you go and try and integrate this, you will not be able to. And I won't be able to. It's impossible to do. But you can show it's an odd function. And if you show it's an odd function, you're done. The answer is 0, right? You don't have to work it, right? It's done. But you have to show that's an odd function. So in my solution videos, I think I do that. So what are the key things that would tip you off to like, hey, maybe it's this property or the one before this? These would have to be the same, just opposite in sign. If this was changed from like negative 4 to 10, all bets are off. Okay? Can't do it this way. All right. All right. Canvas was down earlier. I sent out an email earlier this morning with the homework assignment that goes with this stuff. What I'm asking you to do is go back and go through some of the sections that we've already done your homework in. And in the past, I told you to ignore the numbers. And now I'd like for you to just go back. I gave you certain problems to look at. Go back. If you did your homework, you've already worked through the antiderivative part. All you have to do is practice the evaluation part. And that's something you have to practice. I know the problems I gave you is very simple. Plug pi into cosine, right? Plug 1 into x to the 6th. That's easy stuff. But you need to go back and start, plugging things into like arc sine and work with some things you haven't worked with in a while. If Canvas does not come up, I don't know what we're going to do. Guess we'll just take the rest of the semester off. I don't know. But just look for it, all right? Hopefully Canvas will be fixed today sometime.
We can prove Riemann. So.
We can do the Riemann hypothesis. All right, what I'd like to do now in the last bit of time we have here is I'd like to prove to you what we've known for a long time, and that's the area of a circle is pi r squared. So if I give you a circle with the radius r, we all know, because we were told, and it's on every, on the formula sheet of every math book, that the area of a circle is pi r squared. Let's prove it. All we know how to do right now is if someone gives us a curve, we can find the area of underneath it, so long as we can integrate the function, right? So we need to somehow look at that as a function. But is a circle a function? No, fails the vertical line test. So it fails to be a function of x. So I can't quite do it that way. Instead, what I could do to try and simplify it is how about we just focus our attention on perhaps one quadrant, just this arc right here. All right, and maybe we can find the area in that little segment. And whatever that area is, because of symmetry, multiply the answer times 4. Would you all agree we would have it? But what you need to do is actually come up with a way of representing that curve. So think about this. We've oriented, like this is the origin, x-axis, y-axis, and we have an arc of a circle that comes through like this. And of course, where does it hit here and here? It hits at r, doesn't it? Because that's the radius. Hits up here at r also. Can you come up with a formula like this right here, right? This was maybe sine x or x to the 5th power, right? Like what function is that? Do you know anything about circles? Tell me anything you know about circles other than they're round. Do you have any other valuable information about circles that I should know? 360 degrees, yeah. Pi, that would be from 0 to, this would be 0 to pi, I agree with that. Any other information? Any equations involved that you might know about circles? The arc length? Yeah, there's a formula for that, right? We'll actually prove where that formula came from later. You have to know what the equation of a general circle is. Say it again? Yeah, okay, that's the one. All right, so we have to know this formula. This was given to us at some point in time. Not today, not this semester, earlier. This was in pre-cal or in college algebra. This is the general formula for a circle that has a center at the point HK, and it has a radius of r. Does that look familiar at all to you or not? I mean, if it doesn't, it's okay, but that's the general formula for a circle. Now, what is the center of our circle? We're going to orient this so that the origin is here, right? That just makes most sense. Let's not go put it somewhere weird. Let's just orient it at the origin. So what is our equation for our circle? X minus 0, which is x squared, plus y squared equals radius. Well, our radius is r, so r squared. That is the equation. That's the general equation of a circle centered at the origin. So there's two general circle formulas. One if you want to move it around, and the other one is when it's at the origin. That's the one I can use. Now, when we had our sine function, we were writing like f of x was sine x, right? But wasn't f of x always another way of saying y, like y equals sine x? Y equals this, y equals that, and when we replace y with f of x? So when you look at this equation, if you can solve it for y, won't that be your function of x? Solve this for y. So take that, solve it for y. Let's move x squared over. You get y squared equals r squared minus x squared, yeah? Square root both sides. Now when you come in square root, though, you have to always remember plus or minus. You can't forget that. Square root of r squared minus x squared. And this is why this is truly not a function, because you get the plus or minus. That means if you have an input, you're going to have two outputs. And so that's why it fails. But if we just look at one of them, it should be a function. Which one should I look at, the positive or the negative? Why the positive? The positive should give me positive y values, right? Let's just look at that one. So if I were to ask you right now, say, hey, let's go graph that, what it would draw is this. It would draw the top half of the circle. And then if you look at the negative root function that we threw out, it would draw the bottom. And individually, they're functions, right? But together, they're not. You all good with that? So when we look at this right here, we can say that this is y equals root r squared minus x squared, right? That's our function, f of x. You know what to do now? I want the area under that, right? You're going to set up a definite integral. What's that definite integral going to look like? Where do I start from? 0. Where am I stopping? R, right? Because look, you're going to go from 0 to r. And then what's the function you're integrating? Square root of r squared minus x squared dx, right? Now r here is some constant, right? That nobody is giving me? It's just some, well, someone's giving to me, but it's not changing. It's not a variable. Questions? Okay, you get to integrate that. How are you going to integrate that? Trig sub. Trig sub. You see square root? This looks a lot like this, doesn't it? Doesn't it look a lot like that? Yeah. But instead of a, we're using r. So what's the appropriate trig sub for this? A sine theta, right? So for us, I'm going to use trig sub. I'm going to use x is equal to, now I'm not going to use a because this is an r, so I'm going to say r sine theta. Agreed? Then I need all three things. I need that, I need dx, and I need the root. So dx is r cosine theta d theta. And the last part, r squared minus x squared equals, if you went through this, it would be r cosine theta. I'm running out of time. 6 minutes. Since we've done this, is that okay? That you would be okay with that? Okay, got to move fast here. So what I'm going to do is I'm going to say, all right, I'm going to rewrite this integral, but I'm going to leave the 0 and the r off right now. And the reason I'm leaving it off is because I'm about to switch from x to theta. So this is my restrictions on x. X goes from 0 to r. I don't want to put that on the new integral because my new integral has thetas in it. I'll come back to that. So let's just rewrite this. What's this root thing turn into? R cosine theta. What does dx turn into? R cosine theta d theta. R squared comes out because it's a constant. Cosine squared theta d theta. What do you do with that? Half angle. 1/2 is going to come out because I'm using half angle. It turns into 1 plus sine 2 theta. No, cosine. What the hell am I doing? I said heck. Maybe it's a lost cause. All right, we going? Any questions? Can you integrate those term by term? Okay, what's the antiderivative of 1? 1/2 r squared. Actually taking the antiderivative now, so theta, and then antiderivative of cosine theta, cosine 2 theta is 1/2 sine 2 theta, and then I would have plus c, right? But that's because I've switched back to like an indefinite integral just so I can find the antiderivative. That's all I'm doing right now. And we've run into this before. That's bad. So we use the double angle identity. We switch that to 2 sine theta cosine theta. So this becomes 1/2 r squared theta plus, that's 2 sine theta cosine theta, gets hit by 1/2, so all I'm left with is sine theta cosine theta. I'm going to pass around the quizzes that are take home. Sorry, I didn't have any opportunity to give you any more time. Take yours out of there, pass it around, and followed by the sign-in sheet. All right. You know what to do now? You got to go get theta, got to go get sine theta and cosine theta. So this is where we went to the reference triangle. That reference triangle came off of the substitution. Here was my substitution. I know I'm working through this quickly, but arc sine of x over r is theta. So I just took arc sine on both sides. And then my triangle is this. That's my triangle. So let's see if we can write this answer in terms of x. I have 1/2 r squared. What's theta? Arc sine of x over r. And then plus sine theta, which was x over r, times cosine theta, which was the adjacent side over the hypotenuse, which is r. That's my antiderivative, right? Okay, I'm ready to evaluate the integral now. So here it comes. The integral from 0 to r of, what was it, r squared cosine squared Theta d theta. Was that the integral? No. Sorry. Square root of r squared minus x squared dx. That's what we started with, right? Said, hey, what's the antiderivative of that? We had to do our trig sub. And what we came up with is the following. That we have 1/2 r squared arc sine of x over r. I feel like I'm at a university right now. This is the way I used to do it at universities. There's not much talking. I'm just cranking away here. I don't really care if you're paying attention or even following me at this point. Okay, so there we go, right? Now I plug in r first for x, right? And then 0. Let's pay attention to what happens. When I plug in r, what do I get? Okay, r over r is 1. What's arc sine of 1? 1/2 r squared times arc sine of 1. That's like where on the unit circle is your y coordinate 1? Pi over 2, right? So this turns into pi over 2. Plus, what happens here? I'm plugging in r here. That's r over r, which is 1. But look at this right here. R squared minus r squared. 0. That's zeroed out. That's all 0. That whole thing's 0, right? Now, plug in 0 into this. So I have 1/2 r squared. All right, sine, missing a parenthesis there. 0 over r is 0, right? What's arc sine of 0? So where on the unit circle is your y coordinate 0? Right there, angle of 0. So this is going to be right here, 0, plus, now 0 and for x right here, 0 divided by r, 0 and the rest doesn't matter, so that's 0. This whole thing, 0 plus 0 is 0, times all that, this whole thing's gone, right? So all you're left with is this. 0 plus that is pi over 2. So I get 1/2 times r squared times pi over 2, which is 1/4 r squared times pi, and that's the answer. But that was only the first quadrant. So hit that with a 4, and your answer is pi r squared. Did it look? It was just 440 just a second ago. All right, everyone. Check your Canvas email for the homework assignment. We come back, we do improper integrals next. Is it Thursday? Tuesday? Anybody need to sign in? Canvas is up? Okay, so the assignment should be there. Turn in those quizzes next class.
You're right, that is how it is at the university. They're just talking away.
Yeah, I remember those days. That's why I didn't like it. It wasn't very fun to... Or like, I would be like sitting or